protecting groups in synthesis. So you plan a synthesis to produce a given compound. Let's say this one right here, from using an ester. Of course, there's a hydroxy group, an alcohol group. And you say, okay, based on what we learned, if I use Grignard reagent, I can add this methyl right here. And of course, I can kick out the methoxy group, the OR group. And it's all nice and simple. The problem is that this reaction does not take place. So the reason why it doesn't take place, or if it does, it can give you very small yields, is because this alcohol group, the hydroxy group, will react with the strong base that is the Grignard reagent. Remember, we've been talking about Grignard reagents being strong bases. So we have to use what we call a protecting group. But let's look at the problem. So again, the problem is that you have let's just draw it out like this. So if we have a Grignard reagent, once again, it's going to react. It's going to deprotonate the OH instead. So you will end up with the deprotonated alcohol, oxygen, and the ester group is left alone. Now, that's not the desired product. You can compare them and see that these are not the same. So what we do is we can say, okay, let's actually, we use the word protect, but in a sense, let's hide this OH group. By hiding it, meaning it making it less reactive. So you have to do something about this H. So to protect the alcohol, and this strictly applies to alcohol only in this example. So just an alcohol. So the protecting group is called silyl ether, and the most common one is tert-butyl dimethyl silyl ether. So we just, shorthand is TBDMS. Again, tert-butyl dimethyl silyl ether. So you have a silicon atom. You have two methyl groups. And of course, the R group in here would be the tert-butyl. So it's going to be a big molecule. So let's take a look at how it protects the reaction. So if we have an alcohol and react this with TBDMS, and if we use a base such as pyridine, then we can replace this H, basically this H, with the protecting group. So basically this H is replaced with, once again, the silyl ether. So let's look at the synthesis. So we carry out okay. And like I said, the reaction would go like this. You would do a protection first. So by the way, let me draw it. Tert-butyl silyl ether. So this is tert-butyl. Tert-butyl is right there. Let me see. Let me show you. Actually, I'm just going to show it in the example down here. So basically, this is a protecting group. Let me show you. This is after it's been protected. So this right here. So it would look like this. So the Cl is your leaving group. You have pyridine. And now you may, of course, use also the acronym TBDMSCl. So this would be written as TBDMSCl. And then look what happens. That O is now attached to the Si, the two methyl groups, and the tert-butyl. And now we can use Grignard's reagent. Because why can we use Grignard's reagent? Notice that there's no H, no proton. So the Grignard reagent will not react with that oxygen. So you have to use CH3 MgBr, and you have to use excess amount so that it can react twice with the ester, H2O, and you would produce so this is left alone. And now we have the alcohol. Now, of course, we don't, so we made the alcohol. We're almost there. So look at the desired product. Here it is. I'll put the 2CH3, the methyls, so you can see that we added them from the organometallic, the Grignard reagent. So now we need one more step. We need to now what we call deprotect. We need to deprotect. Deprotect means to remove the protecting groups, the group. So to deprotect, we use four butyl groups attached to N. So that's an ammonium. And fluoride ion. So this structure looks like this, in case you're wondering. So you have an N, you have a nitrogen atom attached to four butyl groups. So remember, butyl is 4, so that's 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Remember, N with 4 bonds has a positive, and then you have F minus. So this is an ionic compound. More of a, so you have the cations and the anions. Now, once you deprotect, then you are back with the OH. And I'm talking about this one right here. Very well. So again, if you have an alcohol and if you have an ester or any other group and you have Grignard reagent, organolithium, you need to protect and then add, then protect. The quick reason, don't want to belabor this, but the quick reason for why we have to deprotect with F minus is because the bond, the SF bond, is one of the strongest sigma bonds known. And basically, SIF has 139 kcals per mole, while the SiO, silicon oxide, has 88 kcals per mole. So this is a stronger bond. And that's why the silicon wants to be now bonded to the fluorine as opposed to the oxygen. So that's how the deprotection occurs. Basically, the silicon sees the fluorine, and then now the bonding occurs between the silicon and the fluorine. And of course, the H is protonated.